The review for Chapter 1 test for Honors Math 2. We're going to be talking about mostly absolute value equations and exponential equations. All right, let's take a look at the general form of an absolute value equation. Y equals plus or minus a absolute value of x minus h plus k. This is the key formula you better have in your notes before you take this test. Hk will represent the vertex, and a is going to represent the scale factor. Now, what that means is that you're going to go the opposite direction, right and left, of what's inside the absolute value. Opposite direction, right and left, of what's inside the absolute value. And the same direction, up or down, as what is being added to the outside of the absolute value. The value in front represents whether it's going to get wider, that is multiplied to the absolute value, wider, if it's between 0 and 1 absolute value, or it's going to get thinner or steeper as if that value is greater than 1 absolute value. It will open up if it's positive, and it will open down if it's negative. That's pretty much all you're going to need when you do the absolute value ones. There's a whole bunch of them on there. Most of them will only do one or two of those things. It may only have an absolute value of x plus a value on the outside. That means you only lift it up or down. You don't go right or left at all. And you probably don't make it wider or thinner in that case. It could just put a change inside, which means you shift right or left, but you won't shift up and down, and you might not shift wider or thinner. This one is the hardest one on there, and it's going to do all of it. It's going to shift right and left and up or down, and get thinner or wider, and open up or down. So you got to kind of make all those distinctions on this one. So we're going to start by moving our point from center. So what we're going to do is we're going to shift and find this vertex point by shifting -2. So notice it's the opposite sign of what's in there for the x value. And then same value is on the outside, 6. So we have -2, 6. That's going to be our vertex. From there, we're going to use the scale factor of -1/3. Now, what does that mean? That means we're going to open down, and it's going to be a third wider. So we want to use this t-chart, x and y. Again, this is just y equals absolute value of x. This is what we call the parent graph. If x is plus or minus 1, we're going to get y being 1. If x is plus or minus 2, we're going to get y is 2, plus or minus 3, 3, so forth. So now we're going to just graph this using this information. So I'm going to start my graph at -2, 6. So there's my graph point, -2, 6. Now, why did I write it above it instead of below it? Well, I noticed here that this was negative, so it's going to open down. So I want to write my vertex point above it. Now, it's going to open down a third as wide. So every one of these values has to get times by a third. Now, I could go over 1 and down a third. Sorry, -1/3. I wrote that wrong. -1/3. So I'm going to go, I could go over 1 and down a third, but that's not going to help me much. The easiest one to multiply is that one right there. I'm going to go right and left 3, and then I'm going to do a third times 3 is -1. I'm going to go down 1. So that's what I'm going to do. I'm going to go right 3, down 1. I'm going to go left 3. Notice I'm going from the vertex point, left 3, down 1. So what really are these points? Well, right 3 and down 1 is 1, 5. Left 3 and down 1 is -5, 5. And that's how that opens. Very wide. Still a V-graph. These are V-graphs, not parabolas like we were doing before. These are V-graphs with the absolute value. Okay, let's move on. The next type is going to be graphing this is what we call a piecewise system of equations. So the key here is really that value, okay? You want to pay attention to what the parameter is, where it's going to stop and start the graph. So this is basically saying that from x being less than 3 it's going to follow the top graph. And if x is more than 3, it's going to follow the bottom graph. So that's kind of my key point here as I go. I'm going to mark the point 1, 2, 3. I'm going to plug in the value of 3 to get those endpoints at our piecewise for this side and this side of the graph. So I'm going to put in a 3 in the top equation. If you do that, you're going to get 3. 3 divided by 3 is 1. 1 times negative 1 is negative 1 plus 2 is 1. So I'm going to go to 3 and up 1. Again, I just put a 3 in there. That's how I got the 3, 1. Okay? Now, I can follow this from there down, up, wherever I want to go as I go to the left. Because it says as I go to the left, it'll follow that. Well, I already have a y-intercept at what? At 2. So I'm going to mark 2 as my y-intercept. That's left of that point anyway. That's what my graph's looking like so far. Now, I want to make sure I put a circle around this one because it is not equal to. Pay attention to that when you're doing your test. The not equal to has to have a circle around it. The equal to will be filled in. Okay? I went left for this top equation. Now I'm going to do the bottom equation. It's going to go right, but again, the key point is starting from the 3. So I'm going to start at 3, put that in. 3 minus 5 is negative 2. So I'm still going over to 3, but now I'm dropping down to negative 2. That's kind of my starting point. Now I could start down here negative 5, but that's not going to help me as my y-intercept because this graph doesn't go left from here. It only goes what? Goes right. Goes right from 3. So I want to plug in some other values that are right at 3. Plug in 4. 4, it's going to be at negative 1. 5, it's going to be at 0. Okay, that gives me enough to kind of say, all right, I know what this looks like. And it's going to graph up like that. It does not continue to the left of 3. This second graph does not continue to the left of 3. Just like the top graph does not continue to the right of 3. Make sure you stop them at 3. That's why the parameter is critical as you do these graphs. Okay, next question. Here we have Amazon Prime's doing a promotion, $50 for the first year and $80 every year thereafter. Graph the first 5 years. Okay, this is what we call a step function because once you paid it, you get it for that whole year. So we're going to start on a step function here, and we're going to do years along the bottom, and we're going to do total cost, and that's important, along the right. So this isn't just 1 year, this is total cost that you're paying Amazon over the first 5 years. So let's think about from the moment you sign on with Amazon, until you hit your first year, how much are you going to pay Amazon? Well, first year is $50. So I'm going to mark that here. I'm going to say, hey, okay, this is 50. Okay, so there's my $50. I don't pay it until I sign up, so it's 0. If you never sign up, obviously that wouldn't count, so that's why I put a circle around that. And then it goes straight across until the first year. I'm going to have Amazon Prime for that $50 the whole time, all throughout that year. Once you hit year 1 and you roll over into year 2, now what do you got to pay Amazon? Another $80, right? So that isn't just, don't mark 80. That's how you'll miss it on the test. It's a total cost, so it's going to be $50 plus $80. $50 plus $80 is $130. So if we're going by 50s, there would be 100. There would be 150. You kind of want to keep your scale there. So 130 is probably right about here. Again, I circle it because if I canceled right on that first year, well, then I'm only going to pay the $50 and I won't have to pay anymore. So that would be it. I would be done at the $50. But once I sign up for the second year, I automatically have to make a payment then, and it's going to carry for a whole year. So clear to year 2, and it's going to go out until year 2, paying that $130. That's all I will have paid. And then it's just going to step up how much every year? $80 more. So what's 80 and 130? Well, that's 210. So there's 200. 210 is just above it. Circle that, graph it out. And you keep going. This is year 3. You're going to do year 4, year 5. I'm not going to do all those, but that's how you would do it. Very simple. Okay, next one. Find the inverse of this system. So inverse here just means you switch the x and y. Do not change the signs. That's how you're going to miss this. I see it every single time. Somebody thinks that by taking the inverse, they should just switch all the signs. That's wrong. Switch the x and y. So we're going to switch the 3 and the -1. It's going to be 3 comma -1. It's going to be -4, -2. Notice I'm not changing the signs. I have 5, 0, and I have -7, 2. That's a really easy problem and question. This is the inverse. But kids miss it a lot because they want to change the signs, not the order. You change the order of the x and y when you're finding the inverse. Okay? Let's move on. Oh, I just erased this one. Oh well. Have to live with it. All right, so I'm going to evaluate this top one. This is a little bit complicated for some kids. Again, you just got to remember you're counting how many x's there are. You're trying to make things positive as you do it. So I'm going to try and make this positive. So if you think about that, you have 7 x's on top. Well, let's do the numbers first. -6 divided by 2 is -3 on top. I'm going to simplify everything in the parenthesis before I raise it to the second power. Here I'm going to have 7. I have 7 x's on top, 4 on bottom. So think about those dividing each other out. Or you can subtract the bottom from the top if you'd like to think of it that way. 7 minus 4, or 4 of them dividing out 4 of them on the top will leave 3 on the top. Again, you have 3 y's here, but this is -2. So how do you make the negative positive? Well, I've got to take it down to the bottom. So if you want to change the exponent from a negative to a positive, change it from the top to the bottom, or vice versa, bottom to top. We'll do that on the next one. So here we have 3 y's on the bottom and 2 more y's on the bottom for a total of 5 y's on the bottom. Very simple. Same thing with the z's. This is negative. I want to make all exponents negative as the first step. Or excuse me, all negative exponents positive as the first step. So I want to bring this z up, put it to the second power, and then I just simply add the exponents, if you'll think of it that way. Z to the 6. So the only one that was a little different was the very first one, the x's, and that's because they were already positive top to bottom. I think about those as dividing each other out, 4 of them dividing 4 of these out, leaving 3 on the top. Or you can again just think subtract when they're both positive and they're opposite, add when they're both positive and on the same level, either top or bottom. Okay, and then I have the w to the 0. Well, w0 is 1. Anything to the 0 is 1. So I can just cross it out at this point. Now I'm going to raise everything to the second power. That means times it to itself. Okay, so I have -3 times -3 is +9. Do not write -6. I have a lot of kids who think they're timesing that too. It's really -3 to the second power. -3 times -3. Now I have x cubed raised to the second power. Now when you have a power raised to a power, you do multiply. So this is where I do multiply. If you have a power raised to a power, you multiply. So it's going to be x cubed times 2 is going to be x to the 6. That's confusing because, hey, you just took that, -3 squared made it 9, and now all of a sudden you're doing x cubed raised to the second power and you're telling me it's 6? Yes, because an exponent raised to an exponent, you multiply. A number raised to an exponent, you multiply it to itself. That's the trick, okay? The y's are going to be what then on bottom? If you think about that, you have y to the 5th raised to the 2nd. You should still multiply. It's still going to stay on bottom. Y to the 10th. The z's made z to the 6th on top. Again, you multiply z to the 12th. The other part's gone, so the 0 doesn't matter. Everything's been raised. This is my final answer. Okay, this next one says, find the inverse. Sorry, I'm writing it again because it kind of got smudged. Okay, find the inverse and graph both the original and the inverse of the functions. Okay, so we have y equals 1/2x plus 3/2. All you got to do is switch the x and y, just like we did on the previous inverse question. Switch the x and y, and then solve for the new y. So in other words, I'm going to write x equals 1/2, and then I put a little dash by the y saying, hey, this is the inverse. So x equals 1/2 y inverse plus 3/2, and I want to get that y inverse by itself. Well, how do you do that? Well, I got to get rid of the 3/2 and the 1/2. So I'm going to subtract the 3/2. x minus 3 halves equals 1/2 y inverse. Then how do you get rid of timesing by a half? Well, you got to multiply by the reciprocal. So what's the reciprocal of a half? 2. So I'm going to multiply that by 2. If I do that to the right side, I've got to do that to the left side. So I'm multiplying that by 2. Here, those 2's divide out. I'll be left with y inverse, which is what I want. I want to be able to have it in slope-intercept form. Then I want the x part to come first here. I got to distribute the 2 to have that x part come first. As I distribute the 2, don't forget to distribute on these. That's where I see mistakes made. 2x minus, now what happens with those 2's? 2 divides 2 once, 1 times 3 is negative 3. That's the inverse. This is the original. It wants us to graph both. Okay, that's not super hard. I'm going to start this one at 3 halves, that's 1.5. And from there, I'm going to go down 1 and over 2. Down 1 over 2. I could do that again if I wanted, down 1 over 2. Not a very good graph, but hey, it'll do. Okay, so there's that one. Then this one starts at negative 3, and it goes where? It goes up 2 and over to the right 1. Up 2 and over to the right 1. So this one's a little steeper. Sorry, I marked that point wrong. This one's a little steeper. I should have probably even went there, sorry. So it goes through there. The way it should go is these should match at the line xy being that point. Okay? It should be on this line x is equals y. They should cross at that point. That's how you know you did it right on your graph. If you have graph paper, it works a little better, but if you don't, and I know that you got these equations right, I'll still mark it right. Okay, now we're going to go on to growth versus decay. So this is exponential now. So everything we've been doing before has been kind of linear, or we've been doing some absolute values. Now we're moving on to exponential. Growth versus decay is actually pretty easy, and you should remember this. Again, it deals with whether it's greater than 1 or whether it's between 0 and 1. If it's between 0 and 1, it's decay, meaning it's going down. If it is greater than 1, it means it's growth and going up. So today we're going to do one that deals with an F-150 versus a Silverado. So as you buy a vehicle, obviously you know it goes down in value over a certain number of years. So this just says we got a Ford F-150 that cost $28,000 and it's depreciating exponentially at about 14% yearly. You buy a Chevy Silverado, it costs $24,000, but this depreciates 10% yearly. Okay, write functions that represent the value in dollars after t years. Okay, we can do that, pretty easy. So remember, our general equation is y equals a b to the t. Okay, so this is saying, hey, we're going to have the initial amount, okay, or the purchase price in this case, the initial value, is going to be your a. So this represents the initial value. Sorry, I think I'm spelling initial wrong. Initial value. Okay, and then b represents it's 1 plus or minus the rate. Okay, b represents 1 plus or minus the rate. So in this case, it's depreciating, meaning it's going down. We're going to take 1 minus 0.14 because it's going down 14% a year, and that would give me 0.86. Okay, and then our initial value was 28,000, and then we're going to have that's going to be raised to t number of years. This is for the Ford F-150, so this is Ford over time. Okay, now we're going to do Chevy over time. The Chevy costs less initially, so it costs $24,000. And it depreciates less over time also. It's only going down 10% a year. So I'm going to, instead of 1 minus 0.14, I'm just doing 1 minus 0.1, which is 0.9 raised to the t. Now, it's going to ask a little weird question here. It says, what is the monthly percent decrease in values? So now I have to think, over a year it's depreciating by 14%, going down by 14%. What would that be monthly? Well, that's actually pretty easy. I'm going to say, all right, it's going to depreciate 14%, so 0.14, sorry, divided by 12 months. Let me grab my calculator over here. And I just go 0.14 divided by 12 equals, so this is depreciating by 0.01, so it's going to be 1.2% each month. Okay? Same thing on, well, I guess I don't even need that decimal really. Well, it depends. I'm going to use the decimal, and then that way it's going to give me a decimal as a percent. So that's what you're going to have. Same thing on the next one, you're going to go 0.1, and think about that. That's less than, this was 10% a year, but that's 0.10 divided by 12. Again, that's going to be a little less than 1%. You can just tell by looking at it. So 0.1 divided by 12 is 0.8% each month. So that answers question B. Question C says, when will the Silverado be worth more than the F-150? So you could set these equations equal to each other and try and solve for T. You could simply graph them, which is what I would suggest, and find out where those two cross each other. You can just start plugging in some values and trying it that way also. So let's just guess 5 years, okay? And let's see how close we are. So if we do 28,000, 0.86 raised to the 5 years is going to be, so if I put in 5 for both of these, that's going to be 28,000 times, if I put in 5 for T, that's 0.47. And I do that 20 times 28 is, so this one is now worth 13,172. Okay. Now if I do this one for 5 years, same thing. I go 0.9 raised to the 5th. That's 0.59, which means it's got 59% of its original value left, times 24,000. And I times that by 24. And I end up with 14,171.76. So even though the Ford was originally worth more, it was worth 28 and the Chevy was worth 24. After 5 years, actually the Chevy is worth more because it's depreciating less rapidly than the Ford. Now that's probably not quite the answer. It's probably somewhere in between there. But as you go backwards, you can do 4.8 years or something like that, because it's pretty close. I mean, you look at that, yeah, it's worth about 1,000, but it's going down at least that every year. So I'd probably try maybe a 4.5, maybe a 4, and just kind of work your way around this, plugging in different values for T. Okay, that concludes our review. Thank you.